Now we're going to look at our first Newton's second law calculation. I hope you don't mind if I do my usual thing where I use different notations to get you used to seeing things one way, seeing things another way, and understanding that they're equivalent. We're going to do that as we go. An object with mass of 15 kilograms is pushed to the right by an object by a force of 28 newtons and to the left by a force of 45 newtons. What is the net force on the object? Thing one to do in these questions, whenever you have forces, is to draw what's called a free body diagram. Usually you draw a single dot to represent the object itself. You can draw a box, it's fine. Push to the right by a force of 28 newtons. The arrows to represent forces usually come out of the object. So this is going to go to the right. Okay? So this will be the 28 Newton force, and then to the left by a force of 45 newtons. I've diagrammed both of these forces. This one's taken care of. This one's taken care of, and they're pointing in the correct directions. What is the net force on the object? Now, to be clear, net force is related to mass and acceleration by that special formula for net force equals mass times acceleration. But we're not looking for that. We're looking for what is the net force in principle, which means that you take the forces, pit them against each other, and see what happens. Let's say that right is positive and left is negative, just like on a number line. So like you would usually do in math class. What that means is that we have I'm going to be really obnoxious with the plus and minus signs here. We have a positive 28 Newton force plus a negative 45 Newton force. Now, anybody can see that this is going to have a negative result because the negative is larger. It's also common sense, if you just use your brain for a second, that if something is pushed harder to the left than it is to the right, that it will move to the left, obviously. So whatever the net force or the resulting force on this is going to be, it should be to the left, which in this problem means a negative number. The difference between 45 and 28 is 17, right? So this should be negative 17 newtons. What is the net force on the object? Well, that would be 17 newtons to the left. Notice how when I translate it back into an answer to the question, I translate it into the terms that the question used originally. The question didn't use things like plus and minus. It used words like right and left. So I translate it back into those. What is the acceleration of the object? Be sure to specify both magnitude and direction. Well, for this, I'm going to use F net equals ma. Check this out. We know this now. We know it not because we're going to do mass times acceleration to figure it out, but because we have calculated it. We've tallied the forces. We've pitted them against each other and seen, that F net is going to be negative 17 newtons. Here's the thing where I'm going to use different notation. F net is interchangeable with putting F with a capital letter sigma in front of it. Sigma in math means sum of. So it's common to see net force written as sigma F, meaning the sum of the forces that act on an object. You should get used to seeing that. So let's put what we know into this equation. F net, we already know, is negative 17 newtons. I'll omit the units just for now, so it's not going to be confusing. The mass is given to us in the problem. This is why the mass actually matters. It's a mass of 15 kilograms, and that is times the currently unknown, but soon to be known, acceleration. To solve for acceleration, it's simple algebra. We do negative 17 over 15, and 17 over 15, everyone knows, is 1.13. So this will be negative 1.13 meters per second squared. What does the negative sign mean? Consistently throughout the whole problem, plus means to the right and left means, plus means to the right, and minus means to the left. So that minus sign means to the left. That means that the acceleration is 1.13 meters per second squared to the left. You should always be on the lookout for this. Net force and acceleration have to be in the same direction. Because think about it, if you're pushing on something from multiple different directions, but there's one direction that wins out, that it's as though the object is just being pushed in that single direction, then the object, when it moves, must move in that direction where it's being pushed. There's no other option. So you must come up with an answer that puts the net force and the acceleration pointing in the same direction. That can either be a simple plus minus sort of thing, or maybe if you're dealing with angles, it can be more complicated. And we're going to do that in a minute, so don't worry.